Hello everyone and welcome to the Easy Chemistry channel once again. And today our topic is separation techniques. So there are a few terminologies before we delve into this topic. And since we are doing this O levels and IGCSE syllabus, so although some topics might be very easy, but we are not going to leave them. So as everything is covered in this, everything that is present in the syllabus is covered in a very thorough manner. So let's start with a few terminologies that are related to this chapter. So the first terminology that we are going to be studying in this chapter is a solvent. Okay. Now, what is a solvent? A substance that can dissolve a solute. All right. And what is a solute? It's a substance that can, I would just want to edit this, and that gets dissolved in a solvent. Okay. And now these both, when they are mixed together, they make a solution formed when solvent and solute are combined. Okay, combined. All right. So let's delve into a few examples. So the first example I would introduce is this example of water and salt. Let's suppose we add a few drops, a few spoons of salt into this water. So the salt is going to dissolve in this water, and this is going to form a solution. All right. And this salt is known as a solute. This water is known as a solvent in this case. All right. Now, having said that, we are going to move towards saturated solutions. Now, what is a saturated solution? This is important. Okay. So what happens is, if let's suppose I have this water over here and I add a few spoons of So I add some water into this beaker, and along with water I add a few spoons of salt as well into this liquid. So what happens is that this is obviously, as stated previously, this is going to get dissolved. But what happens now is, the difference now is that I just have added too much salt into this solution, so much that some salt is left undissolved. See, so this salt over here, this salt is left undissolved in this beaker. Now we can say that this solution of salt and water is now a saturated solution. Okay, because you have just added too much salt into this, and the water cannot absorb more salt. We can do one adjustment to this experiment to just make some more salt get dissolved. That adjustment would be to heat this solution. When we heat this solution, the water is going to get expanded. Let's say the water might reach here. So what happens is, that this much space is now free, and the salt particles can now dissolve in a space equal to this area. Okay, this portion. So some more salt can be dissolved in this way, but this also has a limit, and you cannot just keep on dissolving more and more salt like this. All right, now let's move towards another important terminology, which is residue. Now what is a residue? So a residue basically is a substance that is left behind in evaporation, distillation, or filtration, and like there are other methods as well in which residues can be formed, but these are the ones that we are going to be discussing. So we are only going to be discussing evaporation and filtration. We are going to come to distillation in the next topic, in the next lecture, because in this one we cannot go through all of them. So first of all, let's find out how we can get a residue in the process of evaporation. So let's again go back to our example of water and salt. Okay, so we have added some salt into this water. Now we want to separate them. What we do is we just heat it intensely. So what happens is that this water is completely evaporated, and we are left with some patches of salt or maybe some pieces of salt. So this salt is known as a residue. All right, so this is a residue. And by the way, this is how we can get a residue in evaporation. All right, now we are going to find out how we can get a residue in filtration. So what we do here is that we add this time sand and water. Okay, and we want these to be separated. So what we do is we arrange a beaker. All right, after arranging a beaker, we are going to also arrange a filter funnel, and we are going to put a filter paper over the filter funnel, and what's going to happen is that this solution is going to be poured through this filter paper, and you are obviously going to get your sand over here, because sand cannot pass through the thin pores of filter paper. So there is a filter paper over here, this is a filter paper, so this is sand, and the sand is a residue, right? So this is how you get a residue, and here you're going to get this water. So this is a residue that is left behind, and this is water. And by the way, this water is known as the filtrate. Why? Because it has been filtered. So anything that is filtered is known as a filtrate, while the thing that is left behind is known as a residue. Now coming back to the next subtopic, which is purity. Okay, now before starting this purity, I just want to make you go through something. Okay, let's suppose this is a mountain range and you are here somewhere, and what happens is you find out a stream of water, clean clear water, that you get your bottle filled with. Okay, so now you might be saying that this water is completely pure water, but this is absolutely not pure water, because there are lots of minerals and other metals that are present in this mountain, and they get dissolved in this water. Although the water might look very clear, but it still has all these minerals and things, so that's why we cannot call it pure water. So what is pure water then? So pure water is only that water which has these molecules, H2O. It has only these molecules. If there is anything else apart from H2O, then that's not pure water. Okay? If there is any mineral or any other thing or maybe any chemical, so that water will not be considered pure. Okay? So having said that, how can we now identify if this water is pure or not? There is a very easy method for that. We are going to be finding out their melting point and their boiling point. So we need to understand one thing. The melting point of pure water is 0 degrees centigrade. And the boiling point of pure water is 100 degrees centigrade. So what happens is, if you add impurity, let's suppose you add impurity into this water, so the melting point is going to drop. The boiling point is going to rise. Alright? So the melting point could now become minus 4 degrees centigrade. And the boiling point could become 104 degrees centigrade. So this is what this is how impurity can affect the melting and boiling points, and this is how we can identify if water is that we are using is pure or not. Okay, so this was it for today, and in the next topic we are going to be studying the methods of chromatography and fractional distillation and distillation. So take care and goodbye.